my screens, living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvels standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive.
Hello everyone, my name is Tanish Sharma and in this video I am going to explain how the Android starter kit that I developed operates, and I will also demonstrate how to use it. It is specifically designed to develop Flutter applications for Android. So this is the repository. So first we'll clone it, PowerShell, and I will quickly do a git clone my repo here. Yes. So the repo will be with the name lg underscore env. Then let us quickly cd into lg env. We are here. Now let us quickly do a anti-gravity talk. So what this environment basically does is it already has uh, an application in it that is a basic application that we also submitted for task 2. So it contains all the basic functions like the screens or reloading and then clearing logos, KML, sending basic logos and showing 3D KMLs, and we have also provided it with the services, that is the lg service.dart right here. So this file can be used by the agent to talk to the LG rig. I am also running my LG rig in the background and also Google 7a on Android emulator. So this is the application. So now let us quickly start talking to the agent. So the purpose of this repository or this project is that anyone, even if he or she does not has a deep understanding of coding or how to code Android applications, can still talk to the agent and do and explain to the agent what he or she requires. The agent then follows the structure given in the master readme that is in the root folder. So this is the readme file. It understands how it needs to execute different steps and what it needs to follow, and these in the .agent folder there's a folder skills, and inside here are various different folders that define different steps. So the agent, that is the anti-gravity agent, needs to follow these steps in a certain order to create the application. So now let us see it in action. So let us quickly see what this repository is about according to the agent. And quickly in the meantime, let me do a flutter.get to download the dependencies. And then I'll quickly show you the application using Flutter Run to show you the basic application that we are currently having. And then we'll build on top of it. Let's say we can build a tour of the tour of the seven wonders of the world, as it is a basic demonstration and it will also not take much time to develop. So let me quickly do a Flutter Run. And it is starting. So now here the agent has replied. The repository is a Flutter application designed as a Liquid Galaxy controller. It is part of the GSoC 2026 Liquid Galaxy Lab project, specifically for task 2. I think it is reading all of this from the README, and it specifically mentions task 2 because the basic application that is currently within the lit folder is of task 2. That is why. Then it reads that it does SSH connection management, KML visualization. It has LG underscore service.dart. Special features. The repository includes a unique agent header setup as seen in readme.md, which defines a structured pipeline for AI agents like me to follow when modifying the code. So this is the interesting part and what we actually want to implement with this application. So now let us explain to it what we want to build and start building. I want you to follow the agent pipeline and build a KML tool for 7 wonders. The more context that the agent has, the better for the agent to to work on the issue, to work on the project and develop it. Now this might look very similar to what the mentor did in his video, in his explanation live. And you might be thinking, what did I implement it on top of it? So definitely, as that was for web applications, and this is for Flutter applications, so that is a major change. So I modified all the files accordingly. I also kept the LG skeptical mentor, as I really like the idea of having a skeptical mentor that will also make sure that the user actually understands what he or she is doing and why he or she is selecting the particular structural designs or architecture over any other architecture. Also, I've added LG security as in Flutter applications, in Android applications, you need to follow certain particular security measures to harden your application security. So I've added the skills.md file and it handles it makes sure that the dependencies are updated. It makes sure that you are not storing any secret or any important user credential without just openly storing it in plain words or not using Flutter secure storage, etc. for it. So here it is. SSH integrity, the SSH keys should be safe. And I've also added in the code, I've also changed the code reviewer and lg to make them more I noticed that the code was not really modular. So it was writing functions, it worked, but if you try to understand it or make changes later, then it was a really difficult task. So I tried to explain to the agent how we want it to follow the solid principles, the agile iterations and cleanliness, how functions should be broken. For each functions, unit test should be made inside the test folder and how to keep the code separate and clean so that it can be easily understood if it was later dealt with a developer or even if any other agent later tries to work on the same project, he can easily understand how the code operates. So this is the application. As you can see, this is a simple application that was also submitted for task 2. So I am using this application as a reference and passing it to the agent so that he can understand how the LG rig and the controller works, how they talk and communicate with each other. Next, looks like it has asked us some questions. How do you want the tool to behave? Fully automatic. Let us do recommended. Okay, we'll do C. For the one-click connect requirement, what is the priority? Reliability with feedback, speed over safety. So let's go with reliability. One C and two will send it. We'll do accept all. Let us close these files. You see inside the docs folder that it will start doing, it will create its plans here or any other files that it needs to create. See, it created this 7wondersdesign.md. We'll accept it. So this is the file that it just created. Now, does this architecture approach seem solid to you? So it's fine. Yes, it feels solid to me. That is on. LG Brainstormer is now in play. See, it has created all the tasks. So as a developer, we also keep our own checklist and keep ticking off the topics that we have already done, and it is doing the same. So this is the structure that it is going to follow while building the application. And the structure looks fine. First, it should read LG init, then brainstormer, then plan writer, then LG exec code review, then comes quiz master. And the skeptical mentor is free to come into picture whenever it wants. Does this break down sense for our if you approve, I will finalize? Yes, it does. I'm not reading anything, I'm just believing in the AI. And I also tried creating this tool once before and it worked fine. So I'm sure it will work fine this time too. Write in detailed plans, it has created files. So right now has not created any code for us. As you can see, it is only populating the docs folder with different files. So it has added some more text. So this is all the interaction that we are doing with the agent. It is being stored here, and the code writing, the main code writing, will be done in the LG exec by the agent in the LG exec. Need to verify our architectural understanding. Okay, please answer the three questions. So I think the skeptical mentor has come into picture. So I've quickly typed in the answers. Otherwise, the video would be too long. The answers have been sent. The user successfully passed the educational verification phase. Now it is starting with the LGI phase, that is writing the actual code for the application. Okay, so Taj Mahal, Machu Picchu, Colosseum, Petra. So we'll just go forward and blindly accept it. Creating unit test for vendor model and moving to task 2. So as the README that I created emphasizes highly on creating unit tests and keeping the code modular and secure. So it is making sure that all these are followed. It is working, waiting for command completion. Okay, so it is testing the files and creating tests. Is it creating? Yes, it created this vendor model test.dart. Test description. Description. Shouldn't it write a description? Okay. And yes, it has written a test to validate the coordinates. Good. Now it has done some changes in the lg underscore service.dart file. Okay. Important thing that you should keep in mind while working with a system like this is that whenever it changes an important file like lg underscore service.dart, which maintains the SSH connection, you should actually go and see what changes it did, so that it doesn't by mistake breaks the application. So it just added a few imports. Imports are fine. I really liked how it automatically runs commands on the terminal, and then automatically even tests what output the terminal gave. Is it an error? Is it a success message? It reads the output and then later displays the result. And if it's an error, it automatically reiterates on the code that it produced and then corrects it. Really smart AI is, isn't it? And it's working and working. We just accept all changes. And accept all changes. And I should have actually read those, but okay, that's fine. I mean, right now I've created it in such a way that time to time it asks for user input to verify its thinking and the code that it has produced, and also the skeptical mentor. So it is really good and effective for learning and developing applications while learning. But let's say if you're working on a serious project and you can just skip all those steps, ask the agent to do its thing, and maybe go and have lunch, and it will do all the required tasks for you. You can just come back, accept the changes, maybe read them once before accepting them, understand that what it has done, is it secured, is it good enough, and you can test it out on your own on the application, and then you'll be good to go. Refactoring the upload KML and adding tool orchestration methods to LG service. Okay, so I think I understand what it's doing. The LG service file currently does not has methods to start tool. It has only the basic methods like clearing KML, sending logos, cleaning logos, and connecting, disconnecting, and all those basic functions, but not in anything detailed with like dot start tool, dot end tool, dot pause tool, so or functions like that. So I think it implemented those functions. Always run, just run it. We'll accept the changes. Just close it here for now. Let it run. It is analyzing lg underscore space.dart file. Changes. See, it got an error while updating. Somewhere it got an error and it automatically read the error, reiterated on the code, and rectified it, and then again tested it. Service.dart file, finalizing LG service restoration. Okay, so now we are finalizing. It's changing lg underscore service.dart file a lot, but it is a file that should actually stay consistent throughout different applications. So right now I haven't prompted it to do so, but in the future versions, let's say if you are developing an application with this repository, you can ask it to not change lg_service.dart file too much and call the functions from that file and actually change them or build on top of them in any other file so that the service.dart file stays consistent. Except data test. Okay, so it created another test for LG service test.dart and it is testing the KML file right here. Okay, just run it. It's really interesting how it works. Like it can do everything on behalf of me, and I can give it as much control as I think it would require. If I just want to be lazy, I can give it whole control. If I want to stay attentive and make sure that what it is doing, I actually understand that and approve that. I can set up guardrails and benchmarks at different steps and even modify like the .agent folder according to my specific needs if required to uh, to specify different guardrails to the agent so that it strictly follows them. We'll accept these changes. I don't understand why it needed to change something in these functions. So like this was what I was talking about. I should have prompted it to like not change this file because it's a code file, but it's fine, I guess. It's also testing and reiterating. Okay, so now I think it's working on the front end and actually connecting the back end with the front end. The main C.dart file. Thought for 1 second. It is revising the connection logic. All tests passed. Connection screen.dart. We're good to go. Just hope the video is not above 30 minutes. Okay, so it completed the exact phase. Now it's in the code review phase. Analyze, it passes. Yes, it works perfectly. Then analyzing LGENV. Okay, it's running. Reviewing code base for performance, readability, and Flutter best practices. This is a simple application. That is why it does not need, a lot of prompting or a lot of structural or architectural decisions. If let's say I was building as a serious project or something which is a little more complex than that, then we'll have all those questions, but they will not like just prompt at random places. All this will be decided by the LG brainstormer and the LG plan writer. So any questions that the agent wants to ask, it asks in those steps, in those phases, and later it is now just executing and executing code, writing code, testing code, writing tests, and analyzing and all that. Waiting for command completion. Just taking time for analyzing LGENV, check command status, finalizing code review, in project walkthrough. So I think it is happy with the code. The code reviewer approved the code and now it is creating a project walkthrough readme file, finalizing code review and creating project walkthrough, editing tasks. So let's see. Okay, audit for performance. This is what it is performing right now. Then comes the quiz master. So at max 5 more minutes and we'll be ready. It created this walkthrough file. I can see what it did, how it did, and what changes it did, premium UI and dashboard, service layer, domain model, verification status. It also wrote tests for us right here. Once saved, use the start full tool button for a seamless experience. Okay, we'll check all those out. I've completed the 7 wonders of the World Tour KML tool application for Liquid Galaxy. The project now features blah blah blah. Please review the walkthrough for a summary on how to run the tool. Ready to. Okay, so it is not asking us a final quiz. I think it is because it's a simple project and all the questions that actually need to be answered were already answered previously. So that is probably why it is not asking me questions right now. So I'll do a hot restart.
So this is the application that the agent has created. I've already connected it with the rig and it was a success. So now let us see does the main functionality that we tried to create via the agentic workflow was it successful or not? So I clicked on Start Full Tool and let us see what's happening in the background. It cleared the previous logos and the previous KML files and it just uploaded the KML file that is required and the tour should have started. And yes, we can see that the tour has started here. Okay, so there are no place markers or balloons right now, and I think we'll have to reprompt the AI to add those. So we can do that. Also, as we can see that we don't stop on the monuments for much time right now. So we'll have to reprompt the AI to update the pause and the wait timings, and also we can change the camera angle according to our preference. We can also see that the logo has appeared. So let us stop the tour and it has also implemented the required functions like flying to the hometown, sending logo to the leftmost screen. So let us try one, the 3D pyramid. Okay, so is anything happening in the background? Yes, it's uploading KML. It is taking some time. The KML file written successfully. And we can see the 3D KML uploaded and on the rig. So this is all for the demonstration and the agentic workflow was successful to create an application with the minimum required tasks and functions and also on top of it we have added a tour of the 7 wonders. So thank you.
Hi, my name is Shukla. This is my submission for Gemini Summer of Code, in which we have to build a Flutter starter kit. So before I explain you the structure of the Flutter kit, I'm first showing you the application. So this is the home page. It contains only basic task to level features. Uh, while building this application or kit, my goal is to give a strong foundation. So we can easily build a Flutter controller on this starter kit. So it has clean KML, show logo, and clean logo buttons, and a view map page. So let me first go to the settings. This is the settings page where we can enter details and connect to it. So one thing also, if we try to click on any button without connecting, it will show us a snack bar not connected to Liquid Galaxy. If I go to the map page and try to click it here also, it will also show the same thing. So the application is built in a way that until and unless you are not connected to Liquid Galaxy, it will not work. Uh, so it will protect us from unnecessary SSH calls. The application will only work when we are connected to Liquid Galaxy. Basically the features. Now when I connect to it, uh, now when I click on it, here you can see the command is executed. and the Google Earth is moving. So basically, wherever I click on this map, a KML file is sent to the location, Google Earth. Now there is a requirement to use an external API key. So for which I use Google Place API, which help me to suggest locations. So what does I mean that? Let me show you. If I type P here, it may show location name starting with letter P. When I click on that, and it will send KMS to the Google Earth. Now let me explain you the structure one by one. So first, let's start with dependency. Flutter reward pod is used for state management. Then Dart SSH2 is used for SSH connection. Flutter secure storage for storing credential like IP username in local storage. Flutter.env for storing loading environment variable. Shared preferences is used for creating key value pairs. This package help us, like when I close the app and open it again and go to the settings page, the IP username password which I enter will remain on the screen, will not be lost. Now then is Google Maps Flutter, which allow us to show the map. Then DO for networking related things. Now permission handler package allow us to request permission like location, camera access, etc. in an Android and iOS device, and logger for printing beautiful logs. And in development dependencies, we have Flutter test for writing unit and widget test, integration test for writing integration test, and Mockito and build runner for creating fake dependency to make our unit and widget test independent of any external factor like internet. So I have created this Flutter kit on the clean architecture, which promotes separation of concerns. Basically, it means each layer is independent of each other and focused on only one purpose. So the the UI layer is focused on the state management and displaying the widgets. The domain is focused on entities and business use cases. The data is focused on API related things, SSH calls, and data storage. Core contains the injection container Dart file, which is used to inject dependency. Now let me explain you the folder briefly. First is going to the domain layer. This is the layer. If other layers get affected, this layer should not be changed. And if this layer is changed, then the whole data layer and the UI layer will be affected. Now it contains the entities, which is the data that our business requires. So we have connection entities, fly to entity, and orbit entity, and so many. Then there is repository, which contain the abstract methods or and tells what are the operations we can perform. Now then there is place repository. Similarly, uh, permissions and SSH, these all are abstract methods. It is not implemented here. Now then there is use cases. This contains the actual business logic, like fly to location use case, which when we call this method inside the fly to use case, then we are going to fly to a location. So currently when I click on it, LG repository, it move it to the LG repository, and it contains the abstract methods. It does not have any implementation. So also the use cases come under the high level logic, and the implementation of LG repository is is in the data layer. Here you can say all the logics are written here. This is come under the low level logic. Now the high level logic like use cases should not depend on the low level logic. So currently our use cases depend on these abstract methods, and these abstract methods are implemented by the LG repositories. Now here come the injection container. When the use cases ask for like LG repository, since here we are using it, so it will ask for it. So instead of giving it LG repository, we are going to give it LG repository implementation. So and it is look like LG repository. Here you can see it returns LG repository. So the use case doesn't know whether it is getting the abstract method LG repository or the implemented one. So this separates the high level logic and the low level logic. Now then there is data layer, which contains the data sources. It contains the logic for SSH calls, API calls, data storage, and permission implementation. Now then there is models. The difference between entities and the models are entity is the actual logic data that our business needs, and we want that if we change some logic, uh, the entity should not be affected. Models are representation of entity in the data layer. Like if we do not have model and we calling an API, so there are some parameters like latitude and longitude. If they get changed by the Google server or some other server, so we have to update the domain layer, which we do not want. So fly to models help us to do this for us. If any of the parameter here, this thing ever get changed in the response, so we only have to update the models in the data layer, which protects our domain to get unaffected. Now let me show you flow how this happens. Well, let me go to this settings page. Here you can see this is the settings page. Inside this is a elevated button. This connect to rig. Now when I tap on that, here you can see when I click on that, it called the notify.connect. notifier is the connection notifier. Yeah, here can and connection notifier. So the connection provider provide the connection notifier. It is a state notifier provider which help us to update the state, and it contains the connection entity as the state. These are the dependency which it uses, like connect to LG and use case. And the connection notifier contains the connect method. When we call this, it calls connect to LG, and here you can see uh, uh, it is a variable which contains connect to LG use cases. So when I call this connect to LG call dot call method, actually we are going to this connect to LG use cases and call the connect method repository dot connect. Now here come the dependency injector. Let me instead of providing the here you can see this LG provider, which going to inject the LG repository implementation in the uh, in connect to LG, and this is overall the flow of the app, how this work. Uh, when we go to the LG implementation, when it call connect here, it will call SSH service dot connect, and we are able to establish this connection. So this is the overall flow of the how it works. Now let me close you. I explained the structure of the Flutter kit, how the data flows. Uh, now let me explain you the uh, agents folder. Uh, for this, I'm moving to another folder, LG implementation. This is the same thing, but I have cloned it so we can work on it alongside. So I'm going to use the Gemini 3 Pro model as per the requirement. We have to use Gemini model, so I'm going to use it. Hey, I want to create a LG Flutter controller. This is the agent folder. Here there are 6 skills files, and there is 2 workflows file, and there is one the starter kit context. This is specially designed for the agent to reference this file. Now it contains all the overview of our entire project, all the methods that are used, the folder structure, and what principle we follow, how to create if you want to add a new feature, how to do that. So the flow, if you want to add a new feature, like we first add entity, then abstract method, then use cases, then we implement the uh, that abstract methods we created, then provider, create a provider, and then finally UI. So here is written like we create an entity, repository, use case, repository implementation, provider, and then a UI. And also we have added a manipulation for detecting manipulation, and the packages we use after completing the init phase. It make a session state MD file, which is used to help agent to track on which stage it is. Now this is how we are going to how the agent is going to test when it create features, like to generating mocks, they run this command, and to run all test cases, run this for specific cases, they run flutter test and then path of the file. Now these are the methods, and also about files. For camera position, to write in query.txt file, it tells the agent to write, for moving camera position, use query.txt file, and for synchronizing among all screens, use master KML. Also telling the agent that query.txt file do not require any refresh, and the rest of the KML file require a refresh. Now this is the entire overview of our project. Telling the agent that our project follow the solid principles, clean architectures, and SSH golden rule, that never put SSH calls in build method, because when we put SSH call in build method, it build 60 times a second. So if we put SSH call there, the UI might freeze, because an SSH call takes a half a second to create a connection. And in 60 second, if we put it there, it is going to call 60 times a second. And this is overall overview of the file. Now let me read this. Yeah. So it is asking us the project name and target platform and the feature idea. Uh, so the target platform is phone, and currently I do not have any idea. Can you suggest some idea on which we can work? Now let me show you the init file. So init file is the initialization phase. Here this is the first phase where agent start. Now the first thing is that is to read the starter kit context, because it gives the complete overview how the how everything is created. Then it asks for the project name and target platform and first feature. You have seen that it here. It asks that. Now it teaches some fundamentals about the LG, like for moving camera position, uh, uh, which file require might this tell you in LG fundamentals, and ask one questions after explaining it. Then yeah, after completing it, the init phase, it create a session empty and move the to the brainstormer phrase. It contains some manipulation detection techniques. No, the init phase doesn't contain it. Now I have also tell it to use some emojis for a better look. So the project is suggested since you are starting a fresh on a phone. Here are three beginner ideas that are perfect for learning. I'm a curated guide for the seven wonders of the world. Tap a Taj Mahal, LG flies there, orbit around it, and shows an info card HTML around the right screen. Camera control, managing content on different screen, master slave. Hmm, where is the world? The phone asks, where is the Eiffel Tower? You guess if correct, the LG zoom to into the Paris. Mhm. One idea which I might think is good is the World Wonders tour. And but can you suggest more ideas and what you are going to display on the HTML balloons? Now after that we have brainstormer phase. Uh, uh, Here with the agent and user will work together to discuss what they are building, and after the it gives us some option how to approach a problem, and then after brainstorming it asks move this to move us to the engineering check where it asks questions and checking the also that proposed idea is logically relevant or not. Now architecture over preview. Also at the each phase the starter kit is required to read it. Then session state for tracking the, and after the brainstorming phase it design create a design MD. So here also that it asks when the brainstorming phase is completed, it asks for whether the user is satisfied or not, or does it want to modify any changes, or move to the engineering check for question answering. I think an HTML web page pop right on the Google Earth. So, uh, so so let me select a project. Um, I like the earthquake monitor to visualize the earthquake. I think this is will be better. So I want to visualize earth. Uh, I want to choose the live earthquake monitor. Mm. Now after that brainstormer, we go to the plan writer phase after the engineering check is complete. So let me show you the skeptical mentor MD file. So you are expecting over there. So the first step here is that it read again the agent starter the context, ask verification questions, and also here manipulation detection is mentioned. Like here you can see that if the student is passed, then it will move to the plan writer. And let me read this. Awesome live earthquake monitor. This is going to be super cool. Data into KML. Google Earth watches file. This is coding build and flutter build. So here you can see the SSH thing which I told you. It mentioned that and to you show a red circle on the map for a new earthquake. Do you need to refresh? And yes, we need to send a refresh command. So to tell Google Earth that data is updated, read it. Now I'm going to see you the plan writer. So these are the things which is mandatory to do the for in each phase. Uh, I added the .agent context folder because when I'm testing it, it is forgetting about the context file, not working properly. So I added in the each file. Some prerequisite checks if, whether the engineering check is completed or not. If it is missing, and then it will redirect the data. Then it will write the plan, and after that, uh, and we move to the execution phase with context. Now you tapped into the core difference query. The fast lane for movement, but everything visual needs to be there. You nailed it. Let's save your earthquake monitor. Earthquake shows everything hundreds of dots. Might be cluttered but impressive data. Only magnitude, cleaner, focus on real event. Visuals, simple circle, red dots, size magnitude, traffic light, yellow, red, more informative at glance. Uh, the interaction, the LG camera fly directly to the quick location. It is show info, the LG stays put, but balloon pop up on the right side screen with details. Map, phone list, a scrolling list of pics, and a Google map on your phone. Screen showing the dots. Hmm. So I think it is better to show only few, the necessary ones. So I'm going to choose for B. Then uh, I'm confused about this part. I will ask it more. And for third part, I want to both to move to that location and as well as on the right screen. So the info, and I want a list view in the fourth part. Mm, and can you clarify more about the second part? Oh, Uh, this is executor phase, which is after plan writer is completed and two verification checks is completed. Then it will move to the execution phase. Here it write the code following the principles we made, and at the end it run and analyze whether our file app is working or not, if any of the test cases created is failed or not. So this about the how the earthquake dot look on the globe. Every earthquake is a red circle, the size changes. Small quake is tiny dot, big quake is a huge circle. Traffic light, just the color changes based on danger. Small, just a rumble. Look out, and so you instantly know here there is a big red one in Japan without checking the size. More like a warning system, very easy to read, a bit more colorful. Both, and now as engineer, you big choice to make about how we fetch the data. App load data once when you open it to get new picks. You go to refresh. Simpler code and easier to understand flow. Not live. App auto update every 60 seconds in the background. New picks just pop. Truly feels monitoring station hands free. I think I am going for the A option for the engine. This there should be a refresh button. On clicking that we can able to get the data. Uh, for the engineering part, I'm going to choose the option A. There should be a button. By clicking on it, we should get the quicks. New quicks. Now for the visualization, I have spelled out. Are we going to visualize every earthquake or a single earthquake? Doubt. You have get the data when you want it. No surprise there. The answer is both, but at different times. But at a different times. Yeah, when you first open the app or hit refresh, the entire globe hit with many little dot pins, maybe 20, 30 of them scattered across the world. This gives you the big picture. You instantly see where the Earth is active right now. Drill down. When you tap Quake in Tokyo, camera flies smoothly to Tokyo. A balloon pop up with the details. And because before we log this here, how we build it is using the starter kit. We will use USGB API key needed. Satisfaction check. Yes, love it. Uh, I have still question. If when we click on earthquake, we will move to that location and orbit around it. Then other earthquakes are going to be removed from the screen. When you tap a quake in Tokyo, the camera fly there, you see the big red dot for Tokyo. But in the background, you can still see faint dot for other quake nearby. It shows patterns. Earthquakes often happen in clusters. Seeing the neighbors help you understand why this one happened. We send one big camel by the will all dot. We just remove the camera. When you tap Tokyo proof, all other dots vanish and only Tokyo exists. Uh, can you provide the how the page will look in the controller? And I think it would be better to be single quakes at a time, and a button also to display multiple quakes also. Now I'm going to tell you what happen after the execution failed. It will have a verification check where we will going to debug whether our app is working or not. Uh, we can show the errors and the agent will fix it for us. After the verification is done, the app is completely working fine. Then we will move to a complete code review where it will run all test cases one time and analyze the Flutter app using Flutter analyze command. And after that, we move to the quiz section. But at the top of the list, clear everything, then put action. A big white button at the top of the list show global activity. Clears everything, then puts all dots on the globe. Camera flies to a zoomed out view of the world. A list scrollable recent colored circle with magnitude in red, location and time, and subtle tapping on a global view puts a single pin on that location. Fly the LG rig to it and orbits. Opens the info balloon. Uh, Currently, I am not want the orbit feature. Just a display move to that location and I am able to see the earthquake area in red or green or orange based on the magnitude. And there is marker on which we click. We will able to see info card on the right screen. And you can also add a filter on the base of the magnitude we want to watch. Also a date range picker to get the date of data we want to visualize. Now I'm going to show the code review part reviewer, which does the code review. Read the starter kit. It basically check whether the clean architecture are followed or not. Run the test cases. Any dry principle violated, solid principle violated. Uh, Visual traffic light system on the globe. Tap a quick fly to it, no orbit. Shows detail in HTML1 on the right side. Shows only 5 plus magnitude. Data date range picker shows quick from Jan 1st to okay. Before we start engineering, check how the code will look. Entity get quicks call repository started and fly to use case show quick info data layer. I think these are the abstract method and we will build the API URL dynamically UI layer and I think it's look okay. I'm going to proceed to the skeptical mentor. Yes. Let me try to skip it to check whether the uh, we are able to skip it or not. Can we go to coding part? Let me see the question. We decided to have a quick to move the why are we splitting these into two separate? Why do not write one big fetch and fly function right inside the think of just write one big fetch and fly function the right inside. Um, but here you can see that it able to check whether we are not we are keeping this. So it mentioned to answer the question why split get quicks and fly to into what happens if you want to change the area. So we decided to have a get fix use case and a fly to use case. Why we are splitting into two separate classes? Why are not just write one big fetch fly function, right? Widget uh, traffic you want to show green, orange, red dots on the globe. Which file path on the rig should be right? Camel to we and will this need a force effect? The fly to action when the user tab we want to move the camera. Starter key, which specific file in the method specific method in the LG repository are you going to use for it? Does this method use the fast lane or the context lane? Content lane. So I'm going to answer it one by one. Uh, if we separate these two in separate classes because in solid principle it is mentioned to use a class have only one responsibilities and we do not write fetch and fly because it makes the our data layer with the UI. Mm. For the second question, we are going to write in master KML. Yes, we are going to use the refresh method. For the third question, fly to method in the LG repository is going to used. Uh, for the part currently I do not know the answer. Can you provide the explanation for the part which I do not know? Uh, you are correctly identified that we need to separate classes and use force fly to your question. The answer is send query, which write this is the fast lane. Google Earth watches this file constantly. So as soon as we write the coordinate, the camera move instantly, no refresh needed. So uh, now I'm going to proceed to the next step. I think I have given one wrong question, one wrong answer for one of the question. Lie to. I think for this part. So now it is moving to the execution phase. Hello, hello sir. Now I'm going to give you a quick overview. After the execution phase, the reason for that is that the time constraint and the verification phase took some time, and the agents take some time to fix the errors which came. I'm going to show you the chats one by one. This chat is before the execution phase. Now it after the execution is completed, it asks me to verify it, and after the verification, I run the flutter run command, and the first error came is that the agent used equitable package, but it is not installed. So after that, the second error which comes is that here you can see this is a filter of magnitude. When I increase this, the SSH connection is dropping. So this is the second error. The third is that some error in snack bar is present. So it fixed that, and after that, it removed the snack bar, and I told you to add that. And now after that, it told him to change the color to light red. Now after that, the here you can see this 30 days is not working. When I clicking on it, it is not working. So I told him to fix that, and after that, the feature we want to add is added properly and working properly. Now it asks me to add a new feature or enhance existing feature, or focus on testing feature, continuous integration. If we want to add a new feature, we will go back to the brainstorm phase and again do this everything again. And after that, final code review is done, and then it asks me question, what is the difference, why earthquake model is used. So so that the all the cleaning of response related thing is handled by the model, not by the earthquake entity, which is the part of the domain layer. And the second question is that uh, uh, whether the Google Earth is showing changes immediately. So the answer is no. We need to call the force method, and also ask me about query.txt. So it Google Earth continuously watches that, so we do not have to update it or call the force method. Now it asks me question related to earthquake notifier. Why we now use set state? So set state create a problem called prop dealing. Uh, So instead of using the set state, we use revert pod, which build outside the widget tray where state can be easily accessed from there. Also, if we write fetching logic in the earthquake page, we violate the clean architecture. The UI should not deal with any calculation logic. Now it asks me, why did we use the repository pattern instead of just making the API call directly inside the earthquake? So the earthquake come under the high level language logic, and the implementation come in the low level logic. And they both should be independent of each other. Uh, now this is the final question, I think. Yeah, this is which file would definitely need to change. Like it is asking me to which, if we update the API, which layer is going to change. The answer is data layer. Now after this, I told him to update the README, and after that I asked him to create a Git repository and push this code to the GitHub. Now I'm going to demonstrate the app quickly. So this is the home page. We know that much. And here is a new page is added called earthquake page, and here we can filter out the earthquake on based on the magnitude we want. For low earthquake, it will mark a green pointer. Now if I increase the so we have yellow one for medium range earthquake, and for red one for high uh, high magnitude earthquake. And this is the info card telling the magnitude, date, and time, and depth. So let me talk some strength and problem which I occurred during this phase. The first problem is occurred like when after the planning, it is mentioned in the file that to include ask some questions. So it skipped that. The second problem is a small problem. The agent follow the step-by-step process that is mentioned in the agent skill agent. uh, and from init to the code review and quiz it properly, but it did not update the session state, which I told him to add update it later. So it fixed that, and not a very big issue. And I think that is these two problems were came. The strength is that it properly follow the structure. It created the design we want, a pointer fetching the data from the API, and showing the info card in the right screen. So this is the final part. Thank you very much.
So, hello everyone, my name is Vinayak and I am currently a final year BTech student in Information Science and Engineering from Bangalore, India, and I am currently working as a software developer intern at West Pharmaceutical Services, and I am applying for Google Summer of Code with Liquid Galaxy project, and my primary proposal is GSoC video conferencing for Liquid Galaxy. The goal of my project is to transform traditional video conferencing into an immersive multi-screen experience using the Liquid Galaxy setup. So the system consists majorly of three main parts. So the first is our Flutter mobile application. This acts as a controller system which where user can join or create a Jitsi meeting from their phone and can control which participants appear on which screen. Second is each Liquid Galaxy nodes run on Chromium browser that load Jitsi Meet. So I use Chromium's remote debugging protocols with CDP to inject JavaScript into each tab, calling Jitsi's internal set receiver constant function to control exactly which video stream is displayed on each screen. Third is Bash script which handle orchestration. So the Flutter app sends SSH command to the master node and which distributes them all to the other nodes. So I have designed three conference mode here. First is our panoramic mode where participants are distributed across all the screen, all the Liquid Galaxy screen. Second, I designed the presentation mode where the center screen shows a screen share and other screen shows participants. And third, I have designed an active speaker mode where the dominant speaker is automatically detected and placed onto our center screen. For example, as of now I am the dominant speaker, so I'll be kept onto the center screen and other participants will be divided into rest of the screens. I will be transparent about my use of AI. So majorly I've used two AI tools here. Firstly, I used Figma AI to create UI prototype, which we can see here on the screens also. I hope so it is visible. If not, then I already like shared in my proposal at the same time. So and then I've used Gemini as a learning tool to understand WebRTC concept, JITC internals, and stream routing architecture. And however, all architectural decision, system design, and the proposal itself are entirely designed by me, and all those are my work. But for the prototypes, I took help from the Figma AI, and for the learning purpose, I have used Gemini as of now. Now, what makes my proposal unique is that it is not just a visualization project, but it is an infrastructure level solution. It addresses real challenges such as stream routing across multiple screen, avoiding audio duplication across nodes, and building a centralized controller for our distributed system. So, to my knowledge, real-time video conferencing has not been implemented on Liquid Galaxy before. So I have already done a deep technical research and have a strong understanding of WebRTC peer connection, Jitsi video bridge, and its SFU architecture, receiver constraint, and CDP based browser control. I have also proposed a unique feature, which is our local accessibility narration without using any external API, which improves accessibility while keeping the system efficient and independent without using any external APIs. So, Liquid Galaxy is built for immersive experience, and video conferencing is one of the immersive experience which is missing. So this project will fills the gap, and I am ready to build it. So thank you for watching, and I hope so I'll spend this summer building Jitsi video conferencing for Liquid Galaxy.
Hello, my name is Trang Đỗ Thủy. I'm originally from Vietnam and currently living in Barcelona. I'm a wannabe contributor for Liquid Galaxy project this year of GSoC program Google Summer of Code, and this is my first task of installing the 3 virtual machines and installing the virtual rig of Liquid Galaxy. So let's have a look. Okay, so here as you can see, I already have the virtual machine with 3 different machines here, and when I run it, it's seen successfully on 3 machines, 3 screens. And this is my Android phone emulator, and I already connected successfully to Liquid Galaxy. As you can see here, this is the green side, and if I move along in one screen, this is the master machine, everything will move along also. And another way is that we control it by the phone here. So if we move here, it's also reflected in the big screens. Yes, and this is, let's try this. The first one is the Malaga buses. So when we choose the bus here, it's gonna fly to Malaga. Okay, so as you can see here, it moves to Malaga, and here on the left side is the logos and also the icons of the buses. Okay, so we fly to Malaga, and let's try with another one, the Lleida Big Farm. Here, choose this one for example. Select the year. So when we choose like this, we're gonna fly to Lleida. Let's see. Yeah, so we are here in the Saroca farm, and let's try with the second one. Let's see with this one and the year. So we move to another places. Yes, and also yes, also the data is gonna be displayed here. Okay, that's all. Thank you so much.
Hey everyone, my name is Amit Verma and I am from India and I am doing my Masters in Information Technology, and welcome to my Liquid Galaxy Task 1 submission demo.
In this video, I will demonstrate the task 1 was understanding the fundamental of liquid galaxy and get hand with experience with Google Earth. So let's go. So right here on the screen, you can see 3 virtual machine, and we can call middle one is master machine, on the other side is called slaves machines, and to prove they are all working or not. And now for the fun part is I have a pixel phone emulator that is also called pixel 6a emulator, and now started the pixel phone emulator, sorry for that, started the pixel phone emulator and start and run the data space visualization app for the liquid galaxy. As you can see it is running. So go to the setting for check the connectivity, that is my IP address and that is my port, that is a successfully. Now check the, now start the Malga buses. It basically controls this whole liquid galaxy setup with emulator, as you can see that. Start the orbiting and stop the orbiting. Start the environmental session sensors and last one is pig farm. So that is my basic setup, as you can see that. So now thank you for watching my submission demo task 1.
Hello Liquid Galaxy team, my name is Roof and this video is the submission for the task 1, which is the prerequisite for Google Summer of Code Liquid Galaxy. So I can show this on my computer screen.
So as you can see, this is my Liquid Galaxy rig, in which the centermost virtual machine is the master, and the left and the right are the slaves, and all of these are connected through NAT network, but the master is connected through the host only network, so that we can control the master through host. And as you can see, it is, all of them are synchronized perfectly and are synchronized through view sync. So if we open the data spaces visualization application, you can see it has automatically connected to the IP address of the master, because we have to only control the master and the slaves will follow. So if we go in redirect us, okay, so let's select a farm, and then year, and then let's say batch 4. It would give us information about that in here, and if you want to start orbiting, it would start orbiting here. And this is a great tool for education and visualization of things, using multiple monitors and using all of them in synchronized manner. So that's it for my task 1 for Liquid Galaxy Google Summer of Code 2026.
Hello, my name is Mahmoud Mohammed. I'm from Egypt. I'm a final year student at Ain Shams University, and I'm here to show my installation for Liquid Galaxy and running Google Earth on it. But first, let me explain what's Liquid Galaxy. Liquid Galaxy is just running Google Earth on multiple screens simultaneously. It's just multiple devices, and each device has its own monitor connected together with some network architecture that it's panoramic, like the image doesn't end at the edges of the screen. No, it expands to other screens, and the applications for that is fascinating. Like you can visualize geographical locations, you can visualize museums or ancient places, and it will be useful in medical field like visualizing DNA or proteins. It's a 3D, or like visualizing MRI or CT scans. It's fabulous. And each application has its viewer. Like for geographical locations, we use Google Earth to visualize. For other medical field, we will use other viewers to visualize. And let's talk about network architecture. It's master-slave architecture, which one device will act as a master that controls all other slaves. The master is the controller, and all other devices or all other slaves are synchronized with it. Okay, we have here three. We have here three virtual machines running on Ubuntu Linux kernel. That's the master, and the other two virtual machines are slaves. You can run it using more than three screens. The default is seven, but you can run it with any number of screens, like more than three. It will be good. Okay, this is the master and this is the controller for other slaves like that. You can see that the image expand through the edges of the other screens, and there is a Android device, virtual Android device, which is Pixel Generation 6. That will be the controller that we will send the XML file through it to the master, and the master will save it on the disk, and the Google Earth will fetch it and pull it after 2 seconds to visualize it. Okay, and here the application that we will send the Google that we will send KML file. What's KML file? KML is just XML based for geographical locations that we will send attributes like longitude, latitude, and camera positions that we want to see this place from, and the distance that we want to see this place from. Yeah, and here and this application send KML file through SSH protocol to the master slave. And here that's the IP address of the master virtual machine. And here we see that we are connected and the number of regs are three. Okay. Let's go to bus station and let's choose one of them like that. We will see that we will reach this place on the map like that. It's fascinating. Just on the three screens we can navigate like that, and we can zoom in, zoom out, and so on. We can start orbiting like that, and we can start trading, like go to the specific location for the bus station. uh, okay, let's go to another bus station. That's the location, but it's a bit laggy, but it works correctly because internet connection. Okay, let's go to this, and here we go. We can see that we reached the location correctly, and this is the place of this station bus. Let's go to environmental sensors like this sensor, and we can see we reached the location correctly. Um, that's a sensor, and this is the correct location. We can zoom in for more details, and we can start orbiting like that. And last thing will be form, like selecting Saruka form and selecting 2024 year, batch 1, and yeah, that's the location of the farm. You can see. Yeah, we can start orbiting like that. Yeah. Okay. And also from setting here we can clean logo like that. That will disappear. Okay, we can clean XML, KML. You can see that we have cleaned it, and we can go back like that. And we can navigate the map or any place in the world if you have its latitude and longitude and longitude and so on. We can relaunch. It will be relaunched soon. It's just take some time. Yeah, it relaunched. So that's it. In installations, I have faced some issues. I will write documentation. I will attach to the video to share it with others. It will be useful if others have faced the same issues. Uh, that's it. Thank you for watching. Bye.
Hi everyone, my name is Omar, and today I will demonstrate task 1, which is installation of Liquid Galaxy setup, as well as testing it with a data visualization app. So let's have a look. Here is my virtual machine, and here is the data visualization app installed on my physical device. As you can see, it's clearly connected. It's moving a little bit. So let's now choose Malaga buses, for example. Very well. Let's choose, for example, bus 536. Okay, and let's see, for example, now the environmental sensors. Like, let's choose sensor 2. Okay, that is good. Let's now choose the pig farms. Let's see pig farms, for example, Seaworth farm. And everything is working. Let's start, for example, orbiting. Let's try orbiting. Batch 2, for example, and start orbit. It's a bit laggy, but it works. Okay. Okay, thank you guys for watching, and see you next time.
Hi there, this is Tanishq Daharia, and this is my submission video for the prerequisite task 1 for GSoC 2026. So here we go. And as you can see, I have created the Liquid Galaxy rig with 3 virtual machines. LG1 is the master, LG2 and 3 are the slaves, and all of them are connected together, and their control is this Android device, Google Pixel 6a, which is running on an Android emulator. And let's start with the Malaga buses. Let's select any of the buses. Let's select this one. bus 585. If I click on start orbit, it will start to circle around the bus. Let's start the trail. It will shows the way. Yes, okay, let's see the sensors, the environmental sensors. Let's select any of the sensors. Let's select the sensor 2, which is this one. If I click on start orbit, it will start to circle around the sensor. Okay, let's see the pig farms. Let's see the Saruka farm. Year 2024, and let's see batch 5. If I click on start orbit, it will start to circle around the farm, and the batch information, the batch 5 information we can see here as well. Okay, this was me. Thank you.
Hello, Team Liquid Galaxy. My name is Salesh Shukla. I am excited to participate in GSoC 2026 selection process. This is my submission for task 1. In this task, we have to set up a rig containing of 3 virtual machines. One is master and the other 2 are slaves. The master control the slaves. Now, as you can see, as a result, the 3 screens are perfectly synchronized among each other. We have to connect the data space application with the master. I have connected it. Now we can visualize the pig farm data. On the right screen we can see the details of the farm and its batch number and year also. Similarly, we can see the sensor data. If we select a sensor, its details will be seen on the right screen. And we can see also the logos of the Liquid Galaxy. Now similarly we can see the bus data. We can select the bus. We can see the details as others, and we can trail its parts also. As you can see, it's trailing its path. Now, if we have to clean everything, we just click on clean KML logos and everything will be removed. Thank you.
Hello, my name is Chang Doti. I'm a wannabe contributor for Liquid Galaxy Lab for GSoC program this year 2026, and this is my video for task 2 of creating a Flutter apps. So I'm gonna show you what I have created. So this is the code, and this is the Android emulator that I already created, and this is the main dot, the root of everything, and linking to the main home page is with the connected screen that you can see here. So the point of this connected screen is to connect to our SSH and link to the Liquid Galaxy rig, and I got this inspirations from the Liquid Galaxy connections from Mental Vedant. And once we connected, we're gonna move to the next screen, that is in the control screen, where we have everything having here, and we have 5 functions for different tasks. So I have different here functions here. So first of all, I have the same command so that I don't repeat myself every time I do it. It's gonna be authenticated and running the command here and print the error if there's something. And later we have the refresh function, because every time that we send the KML, we have to refresh it automatically to appear or disappear on the screen. And also this is the logo send logo function, and the send parameter function, fly to, and clear logo and clear KML. So to be more specific, I'm gonna show you in the screen here. So first of all, when we send the logo here, it should be on the screen, on the yeah, as you can see here, because I said the set refresh function, so it's gonna be here. And once I send the 3D parameter, also this is the rig here. Yes, I also want to show you about the KML that I created for the pyramid here. So this is the pyramid in Barcelona in 3D and in color red. So I created this one with the base and also the different four different faces. And the base is a rectangular, so it's gonna have 5 point, and the last point gonna be the same as the first one. Also similarly for other 4 faces, but the different faces is the triangle, so it's gonna be only 4 points here. So my 5 the control here will read that KML and process it and to send it to the screen. And when it's done, it's gonna set the state to parameter loaded, as you can see here. Yeah, so it is the pyramid in Barcelona, and if I want to fly to Hanoi, I can show you here. Okay, so this is the way we fly to Hanoi, which is my home city. Yes. Okay, so this is my hometown in Vietnam. And later, if we want to clear the logo, you can see in a few seconds. Yes, now it disappeared. And let's move back to the pyramid, so you can see if one is changed for the clear KML here. Okay, we are flying to Barcelona in a few seconds. Yeah, this is our pyramid here, and if I click on the button of clear KML, in a few seconds it disappears. Yes, so thank you so much for listening. That's my 5s, and
I created the logo here and made it to the KML, and also the KML for the pyramid and the fly too, and I imported it in the YAM file in here. Okay, and thank you so much for listening. That's the end of my presentation.
So hello Liquid Galaxy team, my name is Amit Verma and I am from India, and in this video I will demonstrate the task 1 of Liquid Galaxy. So that is develop a Flutter based Liquid Galaxy control application. The goal of this app is remotely control the Liquid Galaxy system using SSH. So let's go. That is my basic structure of code, and my code is started with entry point application entry point. So basically that is a void main function. So the function is containing the application start from a main function. So I will add a comment and write that is entry point. So basically that is our entry point, and down to the code, that is a root widget Liquid Galaxy application. So the root widget Liquid Galaxy controller, that is defined as a containing of global themes and colors. So I will add command that is collection of global themes and colors. So basically that is a global collection of global themes and color, and down to the code you will see that the home screen. Yeah, so basically that is a home screen. The home screen is provide a visual introduction with animation with Earth and orbit satellite. So this screen is purely for visualization, engagement, and does not interact with Liquid Galaxy. So home screen is a function that is not interact with LG, SSH, and KML files. So I will add the comment. It's also animation part. Animation part. So, and down to the code you will see the navigation part. So from the home screen the user can navigate and user can navigate to the main control screen using the standard Flutter navigated, and down to the code you will see the LG menu. The LG menu is the core of the application. Here all Liquid Galaxy actions such as SSH connection, KML files, KML loading, and camera controller trigger, all of this are controlling. This is the LG menu screen. So I will add a comment and write SSH connection logo. This part is containing the LG Liquid Galaxy logo images of all screen. This function is display the official Liquid Galaxy logo on screen. So there are some containing features like a check the connections and remove KML logos. And now the most critical part of this project, that is a KML 3D KML pyramid and fly to home. So did you see that? That is a fly to home. The longitude, altitude, range, all of these are contained in this, and that is a fly to home. So that is all commands are there, and down to the code you will see that are all connection and disconnections are command are there, and down to the code that is a basic structure of my code. And now go to the demo of my app. So let's go. This is my demo part. So this is my 3 screen, LGFNFN1, LGFNFN2, and LGFN3. So this is my emulator. So I will first of all connected my emulator with my machine and testing my project and send the logo. So my logo is appear on third screen, and clear the logo. And the second one is sending the KML of pyramid. Now I tap to the button on 3D KML pyramid. So my machine is showing 3D KML pyramid, and now I am clear the KML of this pyramid. Now this is the KML are clear, and go to the fly to home. So this is basically my demo session. So thank you for watching.
Hello everyone, I am Samatma Bharadwaj and this is my presentation for task 2 for the organization Liquid Galaxy for GSoC 2026. So I have built a Flutter application which acts as a remote control interface for my multi-screen Liquid Galaxy rig here. So the Flutter application runs on a Pixel 6a emulator and and can send the following commands, which are send logo, and then send pyramid, send fly to Mysore Palace, clear logo, and clean camel. So on pressing send logo, we got the Liquid Galaxy logo on LG3 machine, so that works as expected. Now let me press send pyramid. Yeah, we went to the location of the pyramid. Let me move the pyramid across the 3 Liquid Galaxy rig. So yeah, that too works as expected. It went to LG2 and then it went to LG3 too. LG2 and LG3. So the pyramid moves to both LG2 and LG3. And let me press fly to Mysore Palace. So yeah, we get the card containing details about Mysore Palace here. On pressing clear logo, only the logo of Liquid Galaxy should go away. Yeah, that worked as expected. And then on pressing clean KML, so yeah, the clean KML works as expected. Both the pyramid and the cards KML details KML went away. So hope each of the following commands in the app work as expected. And then it left the LG logo unperturbed. So let us now go deep dive into the code base. So this is a Flutter-based application to control my triple screen Liquid Galaxy rig via SSH. The technology stack it uses are Flutter, SSH2 protocol, and KML. The mobile app is the master controller, which is a client, and then the SSH tunnel is used to establish a secure communication bridge. And then my target is the Liquid Galaxy server, which consists of 3 Liquid Galaxy rig. So the communication flow is the user on pressing a button sends the SSH command, which is written into the Linux file system. So the Google Earth reads that and gets updated. So the basically the important feature, some of the main features in my program are it is extremely robust. It implements auto healing. So when a connection drops, there's an execute method which sends the raw shell commands which help it reconnect before sending the commands. So it uses shared preferences to securely retrieve user-defined IP address and credentials. So now let us see how camera control, which is fly2, is implemented. So it is written in tempquery.txt. The coordinates of the particular place are stored at here. They are stored here at the lookat variable, which are 76.6551 and latitude of 12.3051. So it is written at temp query.txt and this is executed using await. So yeah, that's how camera control works. And then there are three kml.kml files in my program, which are for the 3D shape of the pyramid, and then the info, which is written using HTML and CSS, and then this is the logo KML. So let us quickly brief through that. So this is the pyramid.kml. Mm, so these are each of the 4 faces of the pyramid defined here. And then um, these are the coordinates which are written as the following here. And then the altitude is measured relative to ground. So yeah, the pyramid.kml is pyramid kml is saved as master.kml and is sent to the master, which makes sure that it is also seen in LG2 and LG3 machines too. So and then the other 2 kml, let us see the other 2 kml files. So this is the palace details, which is written using HTML. Uh, so yeah, the HTML it uses uh, to implement the palace details part. And then the logo KML is done using overlay. So a screen overlay, it is hosted at this site, and then these are the coordinates on the screen where we expect the logo to come. So this is the UI UX design of my application. Let us briefly go through it. It uses media query to detect the orientation. It works both in landscape and portrait mode, and then it gives the real-time feedback here on whether LG is connected or not. And then it uses dark mode, and then the widget, and then each of the buttons are gradiently.
Hello, my name is Mahmoud Mohammed and I'm here to show task 2 which is Liquid Galaxy controller application. First, I will show a demo and then I'll explain the concept quickly and I will walk through the code. Okay, let me resize my photo and display other screens. I think it's good. Okay, as we can see here that we have three virtual machines and we have Google Earth running on it. We have master machine and the other two are slaves machine, and we can see that they are synchronized together correctly. So it's working correctly, and we have here Android device which is running on emulator. It's Pixel, and we have here our code. And let me go to main.dart, which is the main entry for our application, and run without debugging. Let's wait until it's running. Yeah, it's starting. Okay, we can see that I'm already connected, so let me disconnect first and then go to home screen. You can see that all buttons are disabled. It must be you need to connect first to be enabled, and the connection of the status, it's a value notifier. It's notified across all screens, so all screens know your connection status. Okay, let me go to the setting. You need to enter the IP address of the master machine and username and password and SSH port and the number of screens. And the number of screens, it's used to calculate the screen number for the slave, for the leftmost slave, which we will display the logo on it. Okay. Okay, and we can from here see my IP address, which is exactly like that. We can press on connect and we can see that we are successfully connected. We will go to home screen. We can send logo. It will be screen overlaid here in this slave machine, and we can clear logo like that, and it's already cleared. We can send it again. Okay, we can fly to Cairo, which is my city in Egypt, and here we go. um, yeah, you can see it from here. It's working perfect. Okay, and we can send the pyramid KML. I choose the desert to display the pyramid, and we can see here that it's shown in all screens like that. Yeah, it's a beautiful pyramid. Okay, we can clear logo like that, and we can clear KML, and we can relaunch Google Earth. We will relaunch the master machine, and all the slaves will be automatically relaunched, as you can see here, like that. Okay. Okay, let me explain. I think we will not need them again. Okay, because I need my laptop first. Okay. Here we have UI layer, which is two screens, home screen and setting screen. These UI layers will communicate only with LG service, and the LG service will communicate with SSH service and setting service. UI layer will not communicate direct with SSH. UI layer will not communicate direct with setting. It will communicate only with LG service. Okay, let me quickly say this important concept here. How we send the command to master machine, we use SSH protocol, and we use commands, and we will send the command through SSH session. And in the master machine, we have HTTP server, uh, which it hosts the KML files, and it's Apache server, and we know for sure it's this path, which is Apache web server root directory, and anything in this path will be accessible, um, and can be downloaded via HTTP protocol through any machine in this network. and we have a query that we need to query Google Earth through a specific file that Google Earth will always fetch it, and we can send the command to Google Earth through it. Okay, important paths. KML.txt. KML.txt is just a list of KML's paths that master machine will load it, and it will display it and render it. And of course, all slave machines are synchronized with the master. And that's path of temp query.txt. Like, okay, we loaded the KML files, but we need to move the camera to these KML positions to show it, to be visualized in your screen. So we need to move the camera to this position. And we have slave, and instead of n we write the number from 2. This is for if we want to make screen overlaying, like sending logo to a specific screen. So we need to write the KML in this slave KMLs. Okay. A note: only the master who receives the command through SSH, and it synchronizes the view across all the screens, as we all know. Okay, let me quickly go through the code. Here, LG setting. It's just a simple class which contains the attributes that we needed to connect through SSH. Like, we need a host number, host IP or host IP address, a port number, username and password, and screen count. Why we need screen count? Just to calculate the slave number, to show the to show the logo in the leftmost screen. And this is constant constructor. Why it's constant? Because if we created object with the same attributes, we don't need to create another object. No, we just need a reference to it. And here, to string function, we override it. Why? Because it's good for debugging. If we need to print an object from this class, it will be printed like that. Okay, let me go quickly. SSH service. We use singleton design pattern in both SSH service and LG service. Why? Because it's one SSH connection. We don't need to make objects for SSH. It's only one object shared across all the project. It's one instance. So as we can see here, it's the private constructor, and here is the shared only instance. We declare SSH client and LG setting, and this is the value of notifier that it will notify the other screens or the other files. Is it connected or not? Are we connected or not? Okay. Here, the connect function. We instantiate a socket which we will give the host IP address and the port number. Um, and it will handle the three-way handshake and all the network layers. It's the low level. And here, the SSH client, we will give it the socket and username and password. Okay, and here, to verify the connection, we execute command like echo connected to make sure that we are already connected. Okay, disconnect, we just close the connection, add make client and setting as null, and is connected false. Okay, why we need require connection? Because the below functions, we need to make sure that we are connected first to execute the remaining code. So we need in each function to check that we are already connected. So just we check on the client, is it null or not. Here is a function of the execute command. We first check it, we are connected or not, and then we call the function run from SSH client and give it the command as a string, and the output of this function is bytes. The output of this function are bytes, so we need to convert bytes to string so we can read the output correctly, and then we return the output because the function return type is string. Here is a function of the upload asset. We know that we have a directory called assets, which include another directory called the images and KMLs. So here is the function that we give the asset path and the remote path, and it will load the file from the asset path, and we will SFTP write to the remote path. We will convert the data to bytes. We will send the data to bytes, as you can see here. Okay, upload string, the same idea that we check the first, and SFTP write. Okay, SFTP write that we open SFTP, and then our mode is to create a file and to write in it, and then we write bytes. The parameter is bytes because from here we already send it as bytes. 1 byte is just 8 bits. Okay, so we send the file or the string as bytes. It's raw bytes for the network to avoid any um, error in the data through the network. Okay, and here's just a friendly error setting service. We use the shared preference. Simply, shared preference is like a tiny little database that it store a key and value, like host number and actual host, port number and actual port, username and the password. This is used for auto connection. If you close your app and you reopen it again, you don't need to enter your data again unless you need that. So it's auto connected. Here is we save the data, here is we load the data, and here we clear the data. Okay, and of course we return the object of LG setting from class LG setting that we already explained. Okay, and the orchestrator or the controller, the LG service. Here the shared instance. I told you before that LG service is already singleton, one shared instance across all. So just the home screen and setting screen all use the same instance, and here SSH service, uh, and of course SSH service is already from here, which is the only one instance. Okay, and the setting, and here is the screen count, and here we calculate the logo screen from the screen count. Okay, and here the connect function, we call the function of connect of SSH service, and we save the data. And the disconnect, we call the function of disconnect from SSH. Require function which check on is connected, value notifier. Load setting, we call the value of setting service, which is here. Clear setting, it's like LG service is just calling the other functions from SSH service and setting service. Here we launch Google Earth. Here we check on the display manager, which is LXDM or LightDM, and check its service status. Is it running? So we will restart it. Is it stopped? So we will start it, and so on. Okay, and here is the query function. This is the string, and we will write it in this path as we explained before in the whiteboard. Okay, and force refresh, I need to explain it. Here if we call this function and we already in tool, so we need to exit tool first, and then this is a command which we will tell the master machine go and fetch this file from the server and render it again. Okay, fly2 this is used in fly2 command, which it will need the longitude and the latitude and the range and tilt and heading to move the camera to this place to be viewed. So we call this query function like that, and we give it the data. And send KML, we need the parameters are asset path and KML file name, and then here we will upload asset to the main directory of the Apache server like that. And here why we need like if the same file like pyramid.kml, if we change it we will create like a parameter which because I need to explain it in a whiteboard, it's better. We have kmls.txt here. We have only one km file, which is pyramid.kml. Okay, and we have pyramid.kml here. we already changed this file, but we didn't change this file. So this file is already cached. Even if we touch it or use touch command, so we change its modification time, but its content is not changed. So if we send the query command to kml.text to make the master machine fetch the file again and render it, it will not, because it's already cached, and it will check, it will see that the same file has the same content, but we changed the pyramid.kml, the content of the file here, but not here. So we need to give it like a parameter that identifies each version of pyramid.kml. So as we trick Google Earth that it will need to fetch it again because it's changed. Yeah. If we don't do that, um, you need to clear KML first, then send the KML. It's mandatory. If we don't do that, we will need to clear KML first, then send KML again. Okay, but this way we can send KML and it will already update it. Why we will need clear KML? Because clear KML will delete the path of that, so Google Earth will know that it's changed, and then we will send it again, so it will know it's changed again, so it will render the newest version of pyramid.kml, not the oldest version. Yeah, let me continue. And here we send pyramid. Send pyramid is just we send the KML, and then we fly to this position. We can write fly to in this KML, but I write it separately here. And this is the longitude and latitude for Cairo. Just we call the function and give it the parameters. And here the clear KMLs. We need to exit tour if we are already in tour. And here we make the size of the KMLs. The text empty is 0 is empty. And then we will go to through each slave and declare the logo with it, and then we will make force refresh, and force refresh will call the search command in query for kml.text. So Google Earth will know that the file is changed, and it will load it again from the server, so it will be empty, so the kmls will be deleted. I hope it's clear. And here we can the send logo. Here just we upload it to the server, and then the important trick is here that when we upload the string, we upload it in the slave screen kml file, which is in kml directory inside the server. If we need to send a specific logo or something to a specific screen, we need to write it in slave screen, slave number. Okay, here we clear logo, we upload a string as a blank kml, and we will overwrite it the slave kml file, so we only deal for the slaves with its kml file, which is slave and its number, like slave2 slave underscore 2 dot kml. So always we will overwrite this file. Okay, and here is the home screen. It's so easy. I here identify the colors to be used below, and here we home screen extend stateful widget stateless, and here that we auto connect. Like first to instantiate state, we call the function for auto connect, so it will load the setting and it then will connect. Here is run command, which takes an ID and a pointer function action. Like I'll explain it in details, like here. Like send logo, we will call function run with logo and the pointer function. Okay, and this is done by the function. And yeah, that's it. That's the build function, which will build the widget tree, the scaffold, which is already build our app bar, and so on. Okay. Okay. Okay, like here in we created a new widget which extend a stateless widget, and just here in build function we have text, and we write the its style. It's the connection panel and its build function. Okay, and the card which will have the ID and the label and the icon and the text and so on. That we'll see that flight to Cairo we have its icon above it and so on. So it's just widgets like column widget, row widget, card, and so on. Yeah, it's so simple. And here is the setting screen, our build function, and so on. Okay, for the time for this video, I'll be so quick. And here is the main dart, which is the main entry for our application. Our theme is brightness, light, and home attribute, which is the first screen that the app will be show it after it's running. Okay, and we have also the widgets connection status, which it will be in the app bar, the red and the green. It will indicate it's connected or not connected, and so on. Okay, I hope it's clear. I faced a lot of issues. For example, why not we write command lg relaunch in SSH, um, and this problem of why not just we touch the KML to text file even if the content of the KML to text is not changed. Why it's not like in a logo, if you write the screen count wrong, um, I will write a documentation and I'll send it later to share with another with other fellows. I think it will be useful. Thank you for watching, and bye.
Hi everyone, today I will demonstrate task 2, which is Flutter app LG controller. So let's have a look. This is my LG setup, and this is my physical device, which I connected it through USB. So let's now open the app. Let's now connect it. The master IP machine, I think it was .6. And yes, I think it's connected. Let's now try the fly home. Yes, it's connected. I did the equation to the Giza pyramids as an Egyptian myself. So let's now try the same pyramid. The pyramid is not showing on the main machine. I don't know what is that, so let's clean the camel and try again. I think it will work this time. Yeah, it works. Let's synchronize across the three machines. Let's clean the camel. Okay. Let's now try to send the logo. Okay, here it is. Very good. Let's now clean the logo. Okay, it's cleaned. And now let's have a look at the code. Itself. So here is our app. These are our buttons. Okay, this is the home screen, and even within the home screen we have the 5 buttons. So here is my file structure. I have data layer, logic layer, and presentation layer. So I will just explain from the data layer itself to see the core implementation of each method. Here is our SSH service. So the first one is the connect, which is this. The connect, all it does is establish an TCP socket connection. Here, it is just simple, and create an SSH client with a password authentication. And the next we have is the send logo. The send logo takes a camel content, and here is our logo. Let's have a look at it. Here's our Liquid Galaxy logo. We just write this. We just write this camel to this path, slave 3 camel, and we have then the clean logo, which is the opposite. We remove this slave 3 camel in this path, and we just refresh command. This is the refresh command just to update Google Earth, and then we have the send camel to all 3 machines. This is used for the pyramid camel. So we write the camel to these 3 paths, camels and camels 2 and camels 3, and we update Google Earth as we did earlier. Then we have the fly 2. This is just simple. It is to fly to the Giza pyramids, the location I set for this task. Here is its implementation. This method takes a latitude and longitude and the camera zoom and the tilt and the editing, as you can see here. And then we have, finally we have the clean slips, which just empty the index file in this path, the camels, the text. So just clean the camel and the 3 slips. And that's it. Thank you.
This is me Sanjay Saw. So this is my task 2 video for Liquid Galaxy community. So so this is my Liquid Galaxy app running in mobile emulator. This is my master VM. This is my first slave. This is my second slave. So I'll first be connecting to my Liquid Galaxy server. So as you can see, I already provided the details and I'm already connected to my Liquid Galaxy server. Now I'll be demonstrating few commands. First I'll be running send logo command. As you can see, the logo is here, it came. Now I'll be running clear logo command. As you can see, it removed from here. Now I'll be running my city, which will take to my current city. So currently I am living in Kottayam. Now I'll be running in send pyramid command, in which I'll be demonstrating my 3D pyramid. So as you can see, this is my 3D pyramid. Now I'll be running this clear KML command. So yeah, you can see the pyramid from where removed. Thank you.